Good afternoon. I'm Eric with Bulldog Foundation Repair. I'm here at a house in Verbena having a look at a basement structure that has some structural issues going on. And I'm going to switch over to my Ray-Ban glasses and kind of film a walkthrough and make explanation of what I'm seeing. Thank you guys. So when I give instructions or directions on the house, I'll do them as if I was standing in the front facing the house. So now I'm on the left side of the house, and this is where I'm going to start my inspection. As you see, you have some cracks here along the left side of the house that have been mortared up. But more importantly, you have this kind of bowing this way. And that's kind of the first evidence that I'm seeing of some structural issues. The next thing I see is that we've got some stair-stepping cracks along this wall. That's indicating a pressure that way and an opening this way. So what we have here is very common with a house with unbalanced fill. So the first thing that we note is on the front side of the house, we have about 8, maybe a little bit more feet of fill against it. And on the back side of the house, there is no fill. It's just open. So commonly what occurs is when the house was built, all this area along the front side of the house was empty. You could have literally walked down the outside of that wall for about that first 3 feet. And you can kind of tell a color change where the soil is visible there. That's probably about the area that was open and filled back in. So once that soil gets filled back in, as it goes through cycles of wet and dry, it contracts and expands. So when it contracts, it'll settle, and then it's sitting there waiting to get wet again to expand. And over the years, generally after 25 or 30 years, it gets fully engaged with that wall, and then when it expands, it puts an immense pressure against the outside of the house from that hydroactive elastic clay soil. That pressure is what causes walls to bow in, but it's also what causes a thing called racking. And racking is when the entire house begins to move in this direction. And that's what I believe is going on here. That is what I'm diagnosing this house to be. And I'm going to take you inside and kind of show you some other movement and more evidence of that. So before we go inside, I'm going to look right here at this back corner. And you see how we have this cracking? These bricks are opening. And I can look down this wall and I can see that it's leaning back. That's clear evidence of racking in this section of the house. So we're going to go inside and see what else the house has to tell us. Oh, here we go. We've got some cracking where the house is moving this way. In the stair step crack, it's already got kind of a lip there. That lippage is another good indicator of racking. And I'm just looking for more cracks as I'm walking down the back side of this house. There should be more right here in this corner. Okay, here they are. Yeah. So you have those same cracks. There we go. See that caulk? That was about as wide as about half my finger, flat wise. So we got some pretty good cracking here. That's indication of a pressure this way, because you can see these cracks are not, let's see, I want to see if they're, yeah. We've got settlement on this corner as well. So in addition to, yeah, here we go. Yeah. So in addition to racking from the pressure from the front, this back section is also settled out and down. So we'll have to take that into account as well. And let's go inside, see what's going on in there. So I'm in the basement, and first thing I notice is that we've got these pipes on the wall. So these are not really doing very much at all for the racking. What commonly happens is people come in and they see a wall bowing, so they want to stabilize it, and they put columns or other framing against it to try to make it stronger. And if it's installed properly, it can stiffen and stabilize the wall section, but it doesn't do anything for the force of that expanding hydraulic soil on the other side of the wall that's pushing against the wall. That force then, if the wall is stabilized with a brace like this, that force will transmit into the entire house because the wall can't bow anymore, but the force is still there, so it makes the house rack to the rear. And that's obvious in what I'm seeing here. The other thing is these things only have little bitty tiny nail attachments at the top. And my video quit there. They only have nail attachments at the top and the bottom. The top, they're only screwed off with 2 tiny wood screws. And they're not even really engaged with the wall. So these are not really doing anything to stabilize the wall. The only thing that they're doing is holding a vertical load on the one joist that they're installed on. And you can see how that kind of joist is twisted and turned to the right. So while these were probably, were well-intentioned, they're not structurally doing any good for this house. They'll make probably one high spot in between the 2 joists, and that's it. They barely hold any load against the wall itself bowing in. So the repair that we have to attempt here, or that we have to complete here, is called a helical tieback with an H brace. So the way helical tiebacks with H braces are designed is you come in 3 feet off the wall, which the first one would be right here. And that puts us right between two joists. And then on either side, we would come in here and we would cut a hole out. We come in on the inside and we take a giant screw that has an 8-inch blade on it and a square shaft out of steel. We have a hydraulic drive head that we use a hoist and chains to hold up. Then we'd run our hoses in through this window to a mini excavator to power it. And we screw that thing in. So we screw it in until it gets past the compromised soil that's on the other side of the wall, that's pushing the wall, and it gives it something to hold on to so you can't pull it out back to you. Then there's a threaded adapter that goes on to that. So a threaded rod sticks out, and then we put 2 4 by 4 by 1/4 inch thick steel columns on either side of it. There's a big, heavy, thick 1-inch steel plate that goes between those and gets welded in place and has a hole in it so that the helical tieback threaded rod adapter can stick out. And you screw a nut on that, and then that will actually counteract the load that's pressing against the house. And it gives a lifetime warranty against future movement in the wall. Those have to be spaced every 5 feet down the wall. So the entire length of those have to be spaced every 5 feet down the wall for the entire length of the wall that is affected. So these 4-inch diameter posts we would just take out and remove. And then we would install the helical tiebacks every 5 feet with an H brace. This section right here where the stairs go up makes it kind of difficult to drive those. So this landing along with these 3 steps, this paneling and the wood that's on this wall would need to come out. Just this section of this wall from that corner to that corner needs to come out so that we can access this area and come in here and drive our pier. Now we would space them so that one goes on this side of the stairs and then one comes over here on the other side of the stairs. And then we'd have one like right here, 1, probably 2, and 3 in this room. 4 on the other side of that wall, and then they would continue going that direction. So it's very obvious where this wall is bowed in here. It's had a lot of pressure against it. And it's even, bound to these pipes in here. That's just notched into the joist and not really holding anything. There's not even a screw in the top of this. There's one screw, but it's not even in the column. So these columns are really inadequate, and they are not doing a thing good for the house, other than just holding the joist that they're on. So one other thing I'm noticing is I'm seeing some old water damage here. Very common in houses that have unbalanced fill and structural movement for the membrane on the other side of that wall to be compromised and to have water ingression through the wall. The other thing that is very common is that when we come in and cut a hole out and screw that helical tie back into the soil, it loosens a section of soil that will likely go down into the water tables, and then it'll allow the water to come back and leak in around the hole where the helical pile was installed. Now we concrete those back up, but the water can seep in behind them and it can run down into the floor. So the next thing that I'm going to recommend for this house is an interior basement water management system. It has a lifetime warranty, and it'll stop where all the water has came in and leaked. You can see obviously water damage around the bottom side of this wood where it's been wet before. And it'll stop that water before it's able to get into the house. You can see right along in there where that wood has obviously been affected by water under the stairs. And you know, another thing, you can see where this has been cut out and it looks like it's been replaced with some plywood in certain places. That's probably due to water, you know, I'm guessing it's due to some water, but you can see a pattern of water right here. So I would guess that it's likely that this material that's on the wall, maybe it was somebody's well-intentioned attempt at waterproofing the wall or trying to seal it up. It's hard to guess on that, you know, that's only conjecture. However, with the system that I'm installing, or the system that I'm proposing to stop the racking or the structural movement, we would start in that corner and we would come all the way around to this rear back corner to install basement waterproofing system to stop future water ingress in these areas. It's just hard to tell, but we can see that there's some good cracks on the wall, and almost certain that that's going to be a necessity. So I'm inside now on that rear left corner, and I think all the pressure from the front, there's a lot more pressure up here on this front edge than there was on the other end. This is bowing in much worse than that was, you know, from there to there. So I believe the pressure from that has moved this back corner, and that's what caused that brick to stand proud and the block to stand proud on that corner. You can tell that it's, I'll move this back a little bit and see if I can find it. Yeah, it's good lip. And you're talking about a 1/2 inch lip there that wall has pushed that way. So I am going to recommend basically the same thing. It's a vertical helical pier. So I think what we're going to need here is, I'm going to see how far that comes down. It looks like it stops over here. Yeah, here we go. Right down here. Okay. Yeah, and so I'm right here, and the reason I think I'm right here is because we have that crack is narrow, 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 and then we come up here to this corner and it's wider. The higher up you go, the more that crack opens and pushes that way. So I'm going to recommend on this side a helical pier on the outside here, another one on the outside here, and another one over here on this side of the window. So 1, 2, 3, 4 helical piers on this rear right corner because it has moved more than is acceptable from the movement that way, and it may continue to settle and move and cause problems on this back corner. So I will get that drawn up and designed. All these repairs that I'm proposing come with a lifetime warranty that's fully transferable. So even if the house is sold down the line or changes hands in for some other reason, the house will continuously be warranted against future structural movement and also against any moisture ingression everywhere where the system is installed, and also where all the structural repairs have been made. So just wanted to share this with you too. This laser shoots a perfect vertical line, so it gives me a level line here, and I've got it centered right there at the bottom in the corner. And you can see as it goes up that this rear wall, because we're on the rear wall, that's the wall against the soil, has leaned back about a good solid 1.5 inches there in the height of the wall. So really, really good clear indication of racking. So I'm doing the same thing on the other side of the room. I was just over there. Now I'm over here on this other side of the room, and you can see it's right perfectly in the corner down there. And as it comes up, it's at least a couple, that's 2¼ or 2.5 inches out of plumb on this back wall in the height of the wall. So it's definitely racking. So this is the left rear corner of the house. I've got the laser right there on the edge of the 2x4 where this door's been framed out. You can tell that it's right there on the outside edge here at the bottom. But then up here at the top, we got about 1/2 inch, maybe 3/4 of an inch of movement where the back is settled. We're showing those interior cracks as well. So this is just very clear indication of racking. All right, so now we're at the rear right side of the house. You can see here at the bottom, it's right on that kind of outer edge of the 2x4, and here it's almost past the middle line, showing the movement on this back corner as well. So it's very clear that this house is a victim of racking. This is a doorway right here in the main room going back into kind of where the garage area used to be. That door was closed up. So if you see, we're right there on that edge. Come up here to the top. We're all the way over into the other 2x4 over next to it. So 2.5 inches of movement right here. That's the same as that 2.5 inches that we measured over there on that back wall. So what we have is all this framing is pushing everything in the middle. That's pushing everything to the back wall. And that's why we are leaning, racking.